Welcome to my channel everybody, viewers. Today this is the chapter about the tangent normal. Okay, and now this video is only related with the theory of tangent normal. And now in my previous video there was some discussion about the tangent. In the first video of the conception of derivative, there is some discussion. Okay. Now again I repeat here the theory of the tangent, and then we also introduce the normal. Okay. Then see, let us curve. This is the y-axis and this is an x-axis, and this is a curve. Okay. And this here is a point. This is P. That is x comma y here. Okay. Now join with the point Q here, and that is x plus del x, and the other we have y plus del y. Okay, and these are joined PQ. Then this is a chord. So now let us assume this curve be a y equal to fx here. Okay, and therefore the equation of chord PQ is y. Let us assume the basic coordinate we have small x, y, and this is a variable, this is capital Y. So y minus as well like y naught, and this is where the slope, we have to find the slope of PQ, and that is the y2 minus y1 by x2 minus xn. Okay, so y plus del y minus y by x plus del x sorry. Okay, and this is here x minus x. So this is the chord of PQ. So that is del y by del x here and x minus x. Okay, this is the chord. Now when Q tends to P there, so I draw the this is a chord like a big formation of a line, but the movement of PQ is nearest to P there. Therefore, in that case, you can says that the del x tends to 0. So therefore, Q point lie on the P. Okay, then del x tends to 0 and del y tends to 0 here. Okay, mathematically this is tends to 0, not exactly 0 there. Okay, so close to P. Okay, that's why it's form a tangent. Then it's form a tangent at P here. Okay, this is a tangent. Now chord PQ are formed to a tangent. So then, therefore, the equation of tangent at P is here y minus y, and so I apply here the limit theorem. This is the limit x tends to 0. Okay, limit del x tends to 0, and that is del y by del x, and this is here x minus x. Okay, we can say this is represented as a dy by dx, and this is x minus small x, and compare with a straight line like y equal to mx plus c. So then you get here as the coefficient of x here is m, so m is called the slope of this line. So this is called the slope of the tangent. So compare with m is equal to dy by dx. So it's a slope at mentioned point. This is P. At P, that is x comma y. Okay, so this is the definition of a tangent. And what is the normal? Sorry, at that point P is perpendicular perpendicular to this tangent, and this line is called the normal. This line is called the normal. Then slope of the normal, therefore the slope of the normal at P xy is the product of the perpendicular lines are to each other, that is m1 into m2 is equal to -1. So as we get this is, let us assume this is the m, and let us assume the slope of normal be m1. So you can write here m1 is equal to, so that is minus 1 by m. Okay, so that is minus dx by dy is the slope of the normal. Therefore, the equation of normal at p, that is x comma y, is y minus small y, and that is minus dx dy and x minus x. Okay, see the carefully, okay, and start carefully here. And now some another point we have to discuss here for some example of car, and how can easily find the tangent and normal. See, for a circle, that is here for 1, for circle x square plus y square is equal to a square is given, and find the tangent at x1 y1, okay, for this curve. Find the tangent at p, that is x comma y1. So then for this curve we differentiate this, that is dy by dx here equal to 0. So y into dy by dx is equal to minus x. So implies that dy by dx is equal to minus x by y here. So then dy dx at x1 comma y1 is equal to minus x1 by y1. So therefore the equation of the tangent is y minus y1, and this is your m, minus x1 by y1, so x minus x1, so that is y y1, and this is x x1, and this is equal to y1 square plus x1 square. You know the point x1 y1 satisfy this equation, so this is equal to a square. Okay, therefore the equation of the tangent be here x x1 y y1 equal to a square. So by this method we can easily find the tangent for the curve like x square plus a square and y square by b square equal to 1 at p x1 is, we can repeat it like x by a square y by b square equal to 1. So this is, so we can easily write here the tangent. Okay, for the competitive exam not needed to find the equation of that, and you can easily this is the tangent you can write here, okay, technically. And for that curve here we use y square equal to 4ax. So for that we can write here y is equal to 2a, and that can be written as x. So and replaced by that. Okay, this is the this is the tangent. Okay, and for the curve here like xy equal to c square, then equation of that equation of the tangent we had 2xy is equal to 2c square. So we can write xy plus xy equal to 2c square. So this is 1 and this is 1. This is the tangent. Okay. So some of the competitive exam you can if we some given a curve, so you can easily write the tangent like that. Okay. So now for the finding the normal, you know, we apply the rules here. If this is the slope of the tangent, and we can easily find the normal slope of the normal here is plus y1 by x1. So this is plus y1 by x1. Then we got the slope of the normal and equation of the normal here. Okay. So now another point we have to introduce here. See carefully. So if you know the tangent like if y is equal to mx plus c be the tangent. Then what happened? And solving these two curves, we use here a theory of quadratic equation. So what happened here? See that this is x square, mx equal to a square here. So x square m square x square 2 mx plus c 2 mx c plus c square here and minus a square equal to 0. So take a common x square and there is 1 plus m square here, and this is 2mc into x and c square minus a square. As this is a tangent, like this is a circle, let us assume this is a tangent. So a tangent of a curve for this circle at a single point, okay, at a single point. So for this is a quadratic equation, we want to get the solution of x. So for that, if we get a single solution of x, so we can use the theorem of quadratic equation, that is, we get a single solution. So that is b square minus 4 is equal to 0. That is the logic for finding the single solution of some quadratic equation. So that's why this is b, 2mc b square equal to 4ac. This is a and this is c. So now 4 m square c square, that is 4 1 plus m square and c square minus a square, okay, m square c square minus a square, m square c square, a square m square, okay. Therefore c square is equal to a square into m square. Therefore c is equal to plus minus a into, okay. So therefore the tangent is y is equal to mx plus c, and c is a plus minus root over 1 plus m square, okay. So for the curve number 2, x square by a square and y square by b square equal to 1. Then we get here the tangent. If we know the slope of the tangent, as m is here given, so we know the slope of the tangent, then we can easily write here this is the equation of the tangent, okay. And with this help and this formula and do the sum problem, okay. Now see y equal to mx plus minus c, we can write here root over, and that is a square plus b square m square, okay, a square plus b square m square. So this is the okay. So in case of circle, for third number point, if the circle be in the form of that x minus alpha whole square, so y minus beta whole square, so that is equal to r square. So we can write easily this is y minus beta as it is, and m into x minus alpha as it is, and plus minus here is r, a means r here, and root over 1 plus m square here. Okay, and use this formula we can solve the problem of tangent normal. Now some point I want to introduce for our example. If for want to introduce here like 1, if y is equal to if Lx plus my is equal to n, be the tangent to the ellipse x square by a square and y square by b square equal to 1. Then find the condition. Then find the condition. Is what? So this is a tangent, given that this is a tangent. So from that we can x square by a square and y square by b square is equal to 1. So differentiate twice x by a square, and this is here twice y by b square into dy dx, and this is 0. So dy and dx is equal to minus x by a square and b square by y here. So at the point, so you can easily x1 for y1, this is 1, this is 1 here. So therefore the equation of tangent, at P, let us assume this is x1 y1, is y minus y1 is equal to, this is m. So x1 by y1 and b square by a square and x minus x1 here. So now let's find here, this is multiplied by that. So y1 and a square, y, so this is y1 square into a square, x1 into b square plus x1 b square. Okay, so that is here. So x1 b square, so y1 a square, and this is equal to this is a x1 square b square y1 square a square, difference divided by both sides, a square and b square. So you get here x1 by a square and y1 by b square, and then by a square. Okay, and this here was discussion with the first point was there. Okay, now again repeat here the finding the tangent here. Okay, and now this is 1 and the given tangent here is Lx and m by equal to n. This is 2. When 1 and 2 are identical, then we can write here, that is coefficient of x here is x1 by a square by here L, and this is equal to y1 by b square by m, and this is here 1, so 1 by n. So from that you can easily write x1 by a square L is equal to 1 by n. So x1 by a is equal to AL by n. So then square. Okay. Same as from this. So y1 by b square m is equal to 1 by n here. So y1 by b, that is bm by n. So squaring both sides and adding from 3 and 4. Adding from 3 and 4, we get there x square by a square. So y1 square by b square here, and that is equal to a square n square by n square, b square n square by n square, and this is equal to 1, you know. Okay, and take a LCM, that is n square. So a square b square n square equal to n square. And this is the condition when this line be a tangent to the ellipse. Okay, now find the normal. Now I want to find
the normal, and this is the here equation of the tangent. Now use this theorem, we have to use easily find the normal. Okay, see, so, and this is with the right hand normal to the ellipse, then find the condition, and this is the slope of the tangent. Okay, this is the slope of the tangent, therefore the slope of the normal is m1, that is loss and change, and it will be a reciprocal a square by b square, and that is y1 by x1. Therefore the equation of normal is y minus y1, and this is the slope of the normal, that is a square by b square, and y1 by x1, and this is we have x minus x1 here, and multiply by this, then we get here y b square x1, and this is again b square x1 y1, this is b square, again x into a square and y1, and this is here a square y1 and x1, and transfer this to the right hand side, so x into a square y1, and this is we have y into b square into x1, and then here we take a common here x1 and y, okay, and this is a transfer to the left hand side, these are transferred to the right hand side, and these are transferred to the left hand side, so you take a common x1 y1, and this is a square minus b square, okay, number 2, and let us assume this is 1, okay, when 1 and 2 are identical, and this is the normal and this is also normal, so these both the lines are same, means identical, so you can use the ratio and coefficient of ratio of x and y and the constant, it will be the same. So for that the coefficient of x here is a square y1, so right here a square y1, so by from the coefficient of x here is this, and here is z here, and same as the previous point, okay, minus b square x1 by this is m, again use this first, okay, so x1 y1 a square minus b square by here, okay. From this, if we take this equal to this, so we can write like y1 and y1 are cancelled, so we get here x1, so we get here x1, so that is equal to a square into n, okay, then l into, and these are shifted to the denominator part, a square minus b square, okay. So we get y1, and that is the minus b square here, so this is multiplied by m here, by m, and also this is equal to this, okay, and the point x1 comma y1 lies on the ellipse, so x1 square by x square by b square equal to 1, okay, and substitute this value of x1 and y1 to this curve, okay, see again, substitute this value of x1 and y1 to this curve, so that is here 1 by a square, and this is the square of x1, so that is a square n l a square minus b square, and this is whole square, and then again here b square, and squaring the value of y, that is minus b square n square, so m square minus b square here, okay, this is 1, And simplify and squaring this, x over 4 by a square will cancel. So that is a square n square by a square. And right at this square cancels, so one this square left here. So n square by n square. And the square of a square minus b square and square of a square minus b square are shifted to the right hand side. That is a square minus b square and whole square. And the n square take in common and divide by this. Okay, so you can easily write here a square by n square. So b square by n square, a square minus b square all to the power n. So this is a square, not n, this is square. Okay, divided by n square. And this is the condition. This is the condition. Okay, this is the condition when this line be the normal to this ellipse. Okay. And the another point, just another point, see careful, okay, repeat it. Another point, I want to see and so the length of the tangent from the extreme point, external point, not extreme, extreme point of the curve, like later this is just a circle, like x square plus y square equal to a square, and this is the tangent, and here is a Q point, that is x1 y1, and then find the length of the tangent. Okay, so this is the later tangent. So you can write L is equal to this length, L is equal to, that is root 2 bar x1 square y1 square equal to x square, and this is the length of the tangent. And students, see how can possible here to finding the result of L here. So this is the 90 degree. Okay, this is the 90 degree, and then this is the hypotenuse we can write here. So hypotenuse, this is we can say that is a O. So this is OQ square, and that is equal to L square, and that is equal to A square. Okay, and that is L square is equal to OQ square minus A square. Okay, so L is equal to root over of OQ square. OQ square is the length of that. Okay, this is the length of OQ square, and that is x1 minus 0 square. This is the same term, that is x1 square, y1 square is square. This is okay, and minus 0 square. See, and for every curve, if we given the image here, so equal to 1. So length from the external point, that is, let us assume this is external point, we can write here like this: x1 square by a square, and this is y1 square by b square here, and minus 1. Okay, so the viewer, enjoy this video, and next video we have to introduce some problem. Okay, see carefully, and this is the best theory for the tangent and normal. Okay, bye everybody.